What's up, guys? Today's April 15th, and I'm gonna do another Lika daily challenge. Um, I've just been doing like some home renovation stuff, so I'm kind of tired. Um, yeah, hopefully I could just do this one and move on. Not really feeling like it today. Okay, so 2537, count number of good subarrays. Given an integer array nums and an integer k, return the number of good subarrays of nums. A subarray is good if there are at least k pairs of indices such that I less than j and I is equal to array j. A subarray is a contiguous non-empty sequence of elements within an array. Wait, what's k? A subarray is good if there are at least k pairs of indices. The only good subarray is the array nums itself. Wait, what's the breakdown? Let me do another example. There are 4 different good subarrays. They want k is equal to 2. Um, how is 314322 a good subarray? Because the pair of indices right here, 3 and 3 are the same, and 2 and 2 are the same. So that's one good one. Another good one is this one. But it has 3 pairs. So they said at least k pairs. Hmm. And then the 4s and the 2 are the 2 pairs, and then the 4 and the 2 over here. This feels like some sort of like you have to keep track of like maybe like some frequency counting type problem. And to do that, maybe we could do like a frequency, which is like a default dict of an int, which the key would be maybe like a number, right? And the value would be its frequency that we've seen so far. And then maybe some sort of sliding window. Yeah, maybe like sliding window. N is the length of nums for, and then maybe I could have left is 0 for right in range n. We want to process the right. Frequency at nums right plus equals to 1. And then we could just have like a pairs count, right? And I guess to be explicit, right? Like our goal is to have this pair count, pairs count to be greater than or equal to k. if frequency nums at right is greater than 2, sorry, if it's greater than 1, I guess. If it's greater than 1, then we know that pairs count can go up by 1. So now it's like this. If pairs count is greater than or equal to k, return the number of good. So then I could have a good count is 0. And instead of if, maybe it's a while pairs count is greater than or equal to k. This is the current left all the way to right subarray is valid. Well, that means that like if this was valid, right? Then anything to the right of it is also valid. Good count plus equals um 0, 1, 2. Yeah, so I think it plus equals the whole thing minus the right. And that's how many good counts using this subarray that we can make. Because they want at least, right? So at least this amount is already met because the 3's are paired up and the 2's are paired up. So if there's like anything else, like a 3, 4, 5, 6, 7, 8, 9, we don't really care. We will say, okay, this is one subarray, but also this is one subarray, but also this is another one. This is another one. So that's why there's n minus right additional valid subarrays. And then I think we just want to shift left up to try to like make it not valid. So to shift left up, we first need to say frequency nums left minus equal to 1. If frequency nums left equals 1. So if after decrementing it, if it's now 1, that means we lost a pairs, right? So pairs count needs to decrement by 1 as well. And then we can't forget to make sure to increase our left pointer. So this is just sliding window stuff. Is that it? And then we just return, oops. Then we could just return the good count when we're done, right? Let's see. Oh, that's interesting. What if it's all one? Huh? Oh, I think I think it matters if the frequency is different. Like if our frequency is 5, that doesn't mean we have 5 pairs. We actually have 10 pairs. Um, that's interesting. I think it's 2 times the frequency nums are right. So if our frequency is 5, then we actually have 10 pairs. Our pairs count goes up by that much. And maybe before, hmm, 2 times 2 times frequency nums right. I think it's something like that. Hmm. Times 11 minus equals. While left less than right. Yeah, maybe like something like that. Yeah. This is interesting. I shouldn't be adding 2 times the frequency at nums right. Oh, maybe a new pair has been introduced, so plus equals to 2. How many pairs? Minus equal to 2. Maybe something like that. No. Okay, okay. I think if um it's gonna be different. If it's 2, then okay, if it's 2, then yes, we have a new pair. However, if the frequency nums outright is greater than 2, then all of a sudden we have, like, if there's 3 1s, then there's 1, 2, wait, 1, 2, 3. Then there's 3. But if there's 4, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Wait, what? If there's 4 digits, then we have 6 pairs? How does that make sense? Oh, is it 4 times, is that 4 times 4 minus 1? So that's 12 divided by 2 is 6. So is that the same for 3? 3 times 3 minus 1 divided by 2 is what? 4 times 2 is 8, divided by 2 is 4. Oh wait, no. I'm saying when there's 3. So it's 3 times 2 is 6, divided by 2 is 3. Okay. How about when there's 2 digits? It's 2 times 2 minus 1 divided by 2. 2 times 2 is 4, divided by 2 is 2. Cool. And then just to double check, if there's 5, we could do 5 times 5 minus 1 divided by 2. So 5 times 4 is 20, divided by 2 is 10. That's how many pairs. So I just need to, it's not really a plus one, it's a whole equation that I'm missing out. And that equation, I might be double counting and I'll fix that in a bit, but let me at least write the equation. That would be, so NF is like the new frequency, is frequency nums, right? If the new frequency is greater than or equal to 2, then pairs count plus equal to the new frequency times new frequency minus 1. So if we multiply that and then divide the whole thing by 2, that's how many additional pairs, right? Like if there was, the frequency was 5, all of a sudden we could have 10. But then in the past we were doing this. So don't we have to minus 6 first? Maybe. Probably. And then I think the same thing goes here. So let me run this. It's not gonna work. It worked for that, but not this one. Yeah, this one is just because there's not like more than 2 of the frequencies. So it's when there's a lot of frequencies is we're kind of messing up. And that's just because I'm like double counting right here. If it's greater than or equal to 2. Actually, if it's equal to 2, then do this. L if NF is greater than 2, which means it's at least 3, then we want to subtract the 1 before it, right? So the old frequency is equal to NF minus 1, and then we do pairs count minus equal to old frequency times old frequency minus 1 divided by 2, just so that we don't double count right before we do the pairs count plus equals to the new frequency. And then same thing with the pairs count, right? Actually, I don't know. Maybe I'll decide that. Let me run this first. I mean, wait, the first example shouldn't really 1, 2, 3. It should be 10 right at the end. And then it would stop. So why it wouldn't go into this while loop at all. Um Let me print pairs count, and then I could just print left and right just to debug, I guess. And then print in here, and I shouldn't see it. Oh, maybe a couple times? So from 0 to 1, there's 1 pair. From 0 to 2, there's 3 pairs. From 0 to 3, there's 6 pairs. From 0 to 4, there's 10 pairs. Pairs count has to be greater or equal to k. But then I have my pairs count here and it's not. So why would it go so many times? Oh, 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 I see, I see, I see, I see. Okay, okay, okay. So good count plus equals to n minus right is fine. But then when we shift left up, frequency needs to go down. So, um, how am I going to do this? The new frequency is frequency nums left. And then we just need to say if the new frequency it's like the frequency it was 5 and then now it'll be 4. So if frequency is uh, greater than 1 or something, I don't know, we'll see. If the new frequency is still greater than 1, we have to subtract the old frequency. Old frequency is new frequency plus 1. Pairs count minus equal to old times old frequency minus 1 divided by 2. And then pairs count plus equals to the new frequency times the new frequency minus 1 divided by 2. Um, oh, and then this is very easy, right? If new frequency is 2, our pairs count, I don't have to do this. I could just do pairs count is equal plus equals to 1 because a new pair has just arrived. Same with here, like if subtracting the frequency, so this would be the new frequency, right, is what we're left with. If the new frequency is now 1, that means we just lost a good pair, so just minus equal to 1 to make it much easier. Let me run this now. Okay. Yeah, and it should just go in here once. and that's at the very end when we finally reached 10 pairs. Um, that sounds honestly sounds pretty good. Let me remove some of the print statements, and then I think I could just go ahead and submit. Awesome. Okay, so I've been pretty sad lately about these like leak code problems. I think I feel like those hard problems are just like a different level, or at least where I'm at currently. And to be honest, I'm sorry, it's just a little rant here. But to be honest, like I remember when I was first doing leak code, like maybe like half a year ago, easy problems weren't easy for me. Easy problems were like, dude, like how do they know to do that? And then eventually it's like, okay, easy problems are okay. So then now I was doing medium problems. And medium problems, even now, I'm like, dude, a lot of medium problems, I'm like, I don't even know how they could have done that. Especially if it was like graph problems or BFS, DFS, or like Dijkstra's. Like I was no way I could do that. But now when I see like a BFS problem or a Dijkstra problem or a binary tree, I feel like I could just do it very fast. Or like at least it makes sense to me. And um what was I going with this? Like, oh yeah, just like lately, now hard problems are really hard for me still. And that just goes to show, I think if you just keep doing some, like keep practicing, you'll get better. So it's not like the end of the world that I can't do hard problems right now, even though it's like makes me pretty depressed. But going back to this problem, I thought this was quite tricky. There's like some things that we need to realize, like that whole formula. I didn't really think to do a formula initially, right? Because initially I was just saying, hey, if we run into a new pair, maybe we just add the number of pairs. But we have to always make sure that the number of pairs are up to date. Like if we had four of the same number, we have that doesn't mean um, that there's going to be four pairs, right? That means that there's going to be 4 times 3 divided by 2. There's actually going to be 6 new pairs, right? Um, and that was the biggest part. But other than that, it's just sliding window. And then this while loop is just like while the current sliding window is valid, let's go ahead and calculate how many subarrays will attribute to our answer. And then after doing that, since we're done with this valid subarray, let's shift our left pointer up by 1. But then when we shift up by 1, we need to make sure to update our pairs count accurately. And then after we shift it up by 1, it's possible that it's still valid. That's why we have a while loop here. So while it's still valid, keep adding to our good count and then keep shifting up left. Keep doing that while it's valid. And then we slowly keep moving right along until we reach the end. And then we could just return good count. Okay. Time complexity, let's see. So for loop that goes, so this is O of n for sure. And then it's just 2 pointers, and then this one's slowly going up as well. So okay, so I think what this is it is linear O of n time, and then it is also linear O of n space. Just because we have to have extra space to hold this frequency dictionary. So let me see if I was right on that. I'm always kind of like weird about this. Is O of n and O of n. Yeah. Um, they made it so elegant. What? Oh, if the hash map goes down, then the pairs go down the that frequency. Interesting. So I guess I overcomplicated things, but I'll leave it in. And then for just like to, because this was kind of a stretch, and I guess there's a much easier way to do it. Instead of just adding pairs count plus one, you just want to add pairs count to whatever the frequency was before. Huh. Right? Something like that. I don't know. I have to relook at that. But I mean, this is a lot cleaner, right? But happy I was able to do this one, and thanks for watching.